houses. So what's in the house? We also have a floor plan. And we also have a number of toilets. We also have a number of bedrooms as well. So with C, with normal C, you will have to declare these again in these two structs. You don't have classes in C. So you will declare a struct building with floor plan and toilet. You will declare a struct house with floor plan and toilet and bedrooms. So the people who invented, the person who invented C++ thought that this is a waste. Right? So all of these are repetitive. And in terms of semantic, it makes sense to say a house is kind of a building. So instead of having to declare all of these variables again, how about we just inherit them from this? Right. So that's the origin of inheritance. And in the terminology, in terms of terminology, this is called a base class because it contains the basic stuff, right? The other classes will need. So in C++, you will, instead of having to redeclare these, you will say, I inherit. The keyword is inherit. You say public. And you automatically inherit all of these variables. Right, so this class can be called a superclass, base class, or parent class. This can be called derived class or child class or subclass. So inheritance is one of two ways to create new classes from existing classes. Let's say this floor plan is rather a complicated object, and we need to have a class for this. So this is not a simple integer or float. We need to have a whole class for it. So floor plan. Floor plan will be included inside a building. And this relationship is called composition. So you can either inherit all the variables from the base class, in which they will be called inheritance, or you can include the whole class as a variable, and that is called composition. Yeah. So this terminology might turn up in the exam. It's not that important to remember, but you better be. Right. Now we have a house inheriting all of these variables from the building. We can say that the house is a building. Thus, it inherits all of these variables. Whereas if we have a composition relationship, then we say the building has floor plan. So for the sake of exam, you might want to remember these, but they're not really that important in terms of programming. Alright, so let's come to a different example. It's a little bit more complicated. So here we have a shape: circle, rectangle, square. Right? In terms of terminology, you say a circle is a shape, a rectangle is a shape, and square is a special case of a rectangle. So in terms of terminology, you can already draw this diagram. But in terms of programming, let's think about what shape does, what shape has, and what other classes can inherit from it. Right? So we have a shape. A shape has what? I guess area. The other classes, circle for example, also have an area, and then a rectangle has an area and two from the programming point of view, you can say in order to not having to declare this again, we will make circle inherit from shape, and we do the same thing with rectangle and square. And the relationship between rectangle and square is also everything that you can apply, any equation that you can apply to rectangle can be applied to a square. To calculate the area, you will multiply the width and the height of rectangle. So rectangle area is width and height. In terms, if it is a square, you also have width and height, except that they are the same. They have the same values, but in terms of geometry, they are still width and height. So anything that you can apply to rectangle can be applied to square. So we don't want to redeclare all the functions that we declared for rectangle in square, and that's why we will inherit everything in rectangle into square. So we have a rectangle, and we declare a function that return a float, calculate area, that will return width and height. In square, instead of redeclaring this again, we would just simply say a square is a rectangle, and we inherit, and this will automatically come to square. We don't have to redeclare it. So the class can be both a base class and a derived class. In this case, rectangle is both base and derived. It is a derived class of shape and a base class of square. Right. Now, so when you inherit a class, then you will automatically have access to all the variables and functions declared in the class, given that you have the correct identifier. So in this case, circle inherits from shape, and shape has this is probably the center of the shape. Then circle will inherit these automatically. It will inherit print automatically. Now these variables are declared private in the shape, so you can access in circle, but we'll come to it later. So in addition to these inherited variables, circle also declares a radius. So if we have to construct a circle object in memory, we will have to include the centers, the radius, and the function print. So this is right. It's just class shape. So let's say we declare a reusable function in shape that we want to call in other classes. So this print function will print out the coordinates of the center of the shape. So it will print out 0 and 0 in here, in the parentheses. When we inherit shape from circle, circle will sort of get a copy of the print function itself, and then when you call print from circle, what it does is, because it is a copy of the print function in shape, it will print out these two numbers. Right? So these two numbers, respectively, in circle is 2 and 3. So for the shape, it prints out correctly 1 and 5. For the circle, because it is just a copy of the shape, it's not specific to circle, it doesn't know that this is a circle, and it needs to print out this one as well. So it would just go ahead and print out the first two numbers. So you don't just inherit the name, but you also inherit the behavior of all the functions that you declare in the base class as well. So let's go back here. Now, as I said before, you will have access to all the variables declared in the base class, given that they have the correct scope. The scope of these two variables are private. The private means that only the class that declares it has access to them. So in this case, even though circle inherits all of these, it truly does have all of these in memory, it cannot access these variables directly. So if we were to do this, we were to set those variables within the circle class, then you have a compilation error because MX is not accessible to circle. There are other ways to access these variables, but setting them directly is not. The print function, on the other hand, is public, so the shape class can access it, circle class can access it, and any outside function can also access it as well. Right, so now we've learned that there are two modifiers. The broadest modifier is public. Right? So when you declare something public in a class, you say the public can access it. So anything that in class A that is declared public can be accessible, is accessible from A, from B, which is the derived class of A, and from the main function. So the main function can call A dot full directly. So this is the broadest scope in terms of broadness. Yes. The other modifier is private. This is narrowest. Anything that you declare in class A to be private is not accessible to anything else other than A. So if A is a derived class of X and B is a derived class of A, then none of these can have access to anything that you declare private in here. Only A can. So the person who invented C++ thought that it would be a good idea to provide something in between, and he invented protected. So when you declare something protected, you say, I can access it, and all of my children can access it. So B, public A, B can access full, A can access full. If C is a derived class of A, C can access full. If D is a derived class of B, then D can have access to full. Right? But anything else can't. Anything that doesn't have any relationship with A cannot. Now, so question: if A is a derived class of X, does X have access to full, which is declared protected? So in here we have protected. Does X have access to full? Yes, no? If yes, why yes? If no, why not? Any idea?
I'd say no, because it's not a derived class, it's a superclass.
Exactly. So it's not just it is a superclass. The mechanism of C++ is that the superclass has no knowledge of anything that the derived classes declare. So when you access the object as X, it doesn't really have any knowledge of full, and the compilation will say, I don't know what you're talking about. It's not really about the scope, but it's about what it knows, what the class knows exists. So in C++, public, protected, and private, 3 modifiers. So in order to inherit class A from B, there are 3 ways to do it. So we have class A with private X, right, protected So int float y and public string z. Private, take public. When you inherit A to a different class, right, you can inherit A as public. So most likely when you do your assignment, you will use a keyword public, B public A. So what that means is this keyword says when I inherit the variables and functions from my superclass, what is the narrowest scope that I can allow those variables to be accessed? So when I inherit B from A, right, private int x has a narrower scope than public. So it becomes a private in B. So B, sorry, it doesn't become a private in B. B has no access to A, so not the case. In terms of protected, so protected is narrower than public. So anything that A declares protected will be inherited in B as protected. The narrowest scope between the modifier that A declares and the modifier that B declares. And also for public, the narrowest scope between these two is public. So Y becomes protected in B and Z becomes public in B. So this is the most common way to inherit things in C++. But you can also inherit A in B as protected. So thing changes a little bit here. When B declares A to be protected superclass, the narrowest scope of the variable Y is still protected. Protected versus protected is still protected. So Y still becomes a protected variable in B. But Z doesn't become public because the narrowest scope between this modifier and this modifier is not public, but it's protected. So Z in this case becomes a protected variable. Does that make sense, or is it too confusing?
Does it leave out the X value?
Sorry?
Does it leave out the private?
Yeah, private cannot be inherited.
So it's, yeah, just protected and public.
Yeah, so the narrow scope of protected and private is private, but the thing is, if you declare something private, then it's not part of the deal.
Yeah.
You don't include it in the list of inheritable.
Yeah.
So we leave out this X.
But if it's inherited from a private?
Yeah, so I just talk about public inheritance and protected inheritance. Now, if we inherit A as a private superclass, then we do the minimization again. So the narrowest scope between this modifier and this modifier is private. Protected is bigger than private. So this Y is declared protected in A. When it comes to B, it becomes private. And Z also becomes private. So the narrowest scope between public and private. Yes?
What if we have several public variables in A and we want to make some of them private in B and some of them remain public? Do we have to declare it several times?
So if you have two public variables,
two public variables, and I want to make one of them private and one of them remain public.
Yeah, I don't think you can do it. You can shadow it, but if you, yeah, I don't think you can do it. Shadowing is a different thing. I'll get back to you. I'm not 100% sure, but I'm like 95% sure. All right, let's move on. So this is just a summary of what I just said. When you have a, so these values are just minimum of these two values. Minimum of public and public is public. Minimum of protected and private is private. But you don't have to remember this table to know how to do it. And you will find. Alright, so previously we declared a function print in shape that prints out the first two variables that you give to the constructor. And these represent the coordinates in a two-dimensional space. However, circle has another variable, radius, and we want it to be printed out as well. So if we call print in C, it will only print first two variables, which is not what we want. We want it to print out the third one as well. So what can we do? Override function. Right? So we're saying overriding is basically saying we provide an alternative. So in this case, in circle, we redeclare print and say instead of just printing out the first two variables, also print out the radius. This is the alternative that circle provides. So when we have that and we call print again in C, the alternative will get invoked and the third variable is in that. So you understand this function overriding? Any problem? You know about function overloading before, so it works kind of similar way. We provide an alternative with the same name, right? And because it's more appropriate to be called, it will be called. So even though circle still has a function, the print function that should provide, it provides an alternative. When you look at the memory of circle, you see two functions. One is called circle scope print, and the other one is called shape scope print. So even though circle still has access to both of these, this one is more appropriate because it's closer to the class. So it's easy to understand. In order to override a function, you need to keep the same parameters. So it's, when you overload the function, you need to have a function with the same name but different parameters, different in type or different in number of parameters. Function overriding is kind of the opposite. You still need to have the same name, but you have to keep all the parameters exactly the same. So if you provide another function print that takes in a variable, this is not function overriding, this is overloading. So when you call print without a parameter in C, it will still call the one declared in shape. So be very careful with this term. If you're confused about these terms, then this is a trick that you can use. So overriding and overloading. When you override function, you provide an alternative and it will never be called. Basically, you get rid of it, right? So you get rid of it. Get rid of existing functions. The existing function. When you overload, you don't get rid of it, it's still there. It can be called with a different parameters. So just keep this in mind. Yeah, so again, same thing we just talked about. Right, so the reason why we override print and circle is because we want to change the behavior. We want it to print out 3 instead of 2 variables. But if you only want to print out two variables, no reason to override. Yes, only do it when it is absolutely necessary. When you do your assignment, I've seen a lot of people sort of just copy and paste existing function in the base class into the divide class. There's no need to do it. If you don't change your behavior, don't do it. And if I was still marking your assignment, that's going to be marked down. But now who is doing it? So, don't know. Function override. Yes, it's just another example. So this slide is about design. You only have this problem if you try to optimize your program prematurely. And when you do your assignment, try not to I forgot the word. Optimize it. But don't try to optimize it, unless it is absolutely necessary. So this slide is about we have a square that is a rectangle, right? And in the rectangle class, we declare the width and the height. So it's int. When you inherit rectangle, when you inherit rectangle from square, you will inherit all of them. Let's say these are public. Even if they're not public, you still inherit them, but that's not the point. Let's say they are public, then square has access to the width and height. Right? The thing is, the square doesn't have two variables. It has the width and the height are the same in the square. So if you are overly concerned about optimization, you might think, oh, it's a waste. Why do we need to have two slots in memory to hold two variables that always have the same value? That's a problem. You will inherit this, so the width here and the height will always be the same. So the question here is, should we make square a class of rectangle, in which case it will inherit these two variables, and every instance of the square class will carry two variables when it only needs one. Or we can make it a separate class. Let's just not do it, and we declare just the width or the length. So in this case, every instance of square will have only one variable in memory. But anything that you declare that can be reused from rectangle is not imported into square. If you have a calculate area function, in here you return width and height. In here you return length square, and times length. But you have to write this again. So you need to make a decision whether you want to make square a derived class of rectangle and sort of waste a little bit of memory, or make two of these separate classes and waste a little bit of computing writing code time. In this simple case, I would say just keep square the derived class of rectangle, because the cost is very small. The cost is only one slot in memory, but the benefit is huge. You have all of these behaviors in rectangle inherited in square. And one slot for an int is really nothing for the computer. So it's not the optimum solution, but it's not a very bad solution at all. And when you design something in real world, then you will very often have to consider these design decisions, whether you want to make class X a derived class of class Y, or you want to make them separate, or you want to make them both derived classes of something else. The optimal solution for this would be to declare something like 4 vertices interface. Right? So this one will a square is a 4 vertices shape. A rectangle is also is a vertex, right? Vertices. And then you declare all of these all of these functions in here. And then you can declare a square being a vertex, 4 vertices, 4b, and rectangle being 4b. This is where we kept it. So that's a third solution. Instead of making this depending on this, making both of them depending on something else, and provide a common behavior in that common base class. Yeah. So so the decision that we have to make is about whether we value coding standard or coding practice, or we value concept. In the case that the two classes are they have real world sort of they represent something in real world, then you want to you want to value you want to prioritize concept, so that when you write a code, it will make your thinking easier. So it's always easier to say a rectangle, a square is a rectangle, and anything that I declare in square, I can use in rectangle, instead of having to think about, well, because I want to make my code less wasting in terms of memory, I declare them separately, and then when it is a rectangle, I have to do this. When it is a square, I have to do this. Another way that can make you sort of decide whether you desire classes in an inheritance way is to ask if it is a kind of. So when you're asking yourself whether you should make a rectangle a derived class of a square a derived class of rectangle, you ask yourself, is a square a rectangle? And the answer is yes. Then you make them depending in an inheritance way. If they are not, then you don't. Composition is basically a fancy word for saying we declare this variable inside this class. So these two variables, you can say shape inherit this variable in a composition way. And if we go back to the previous example about building with the floor plan, and let's say we have a number of bathrooms. When the variable is a primitive type like n, you don't say this is composition, even though the relationship is still composition. You don't really say this is a composite component of this class. But when you have a variable that is a class, this is definitely is a class, because it's rather complicated, it cannot be represented by a simple number. Then you say floor plan, building has a floor plan. So the relationship here is a position. That's it. I hope these don't turn up in the exam. Useless. Right. Again, let's go back to this slide before we go to that slide. The question that you want to ask yourself is, does it make sense to design classes to not represent a concept in order to save some memory, to optimize it, to program a little bit? In this case, you have the opposite problem, right? You have two classes that sort of have the same variables. So in terms of programming, you might want to make, well, okay. Class point has two variables, mx and my. Class shape also has two variables, mx and my. So it is tempting to make class shape sort of a derived class of point, because you can save yourself from declaring these and all the behaviors associated with these. But in terms of concept, shape is not a point. So is shape a point? No, not really. It does have some common attributes, but in terms of concept, it's not. So in that case, you might not want to do this. It would just make your life more difficult when you program.
Would it be better like if it was like triangle and star? If it was like triangle and star, like
if we have another,
like for that
classes.
example, like if you know, the star is inheriting from a triangle, like the properties from a triangle, because it's similar in the points.
Okay, and it is a star triangle. Is it?
Made up of triangles.
Yeah, it's made up of triangles, so you can declare them sort of in a composition, composite relationship,
Yeah.
but not inheritance. Because other than having some sort of very small common, they don't really, all the behaviors are different. To calculate the area of a star, it's very complicated. And the way that you calculate the area of a star is completely different from calculating the area of a rectangle. So if you make this one derived class of this, and you declare an area here, then you would definitely have to override area in star, and not just area, but circumference. Is it circumference? And I don't know, and other properties of a triangle that the star doesn't have. And keep in mind that even when you override something, it's not like you actually get rid of it. It would just be hidden away in memory forever. So you always carry around two copies of the same function, and it's actually not optimized. So even in terms of coding, this is not a good idea to make a star.
When would that be a good?
When would it be a good idea? If you can substitute the base class with the branch class. So let's say you can live in a building. So it could be a house, could be an office, could be a public toilet. It doesn't matter. But if you substitute the word house or office or public toilet with building, does the sentence still make sense? If it does, that's a good idea to make them inherit each other, because that signifies that a house is a building, a public toilet is a building, and an office is a building. So yeah, let's all sort of go down to to semantic. These examples are very clear, but there are true sort of difficult examples that you sort of don't know what to do. If I can find one of those examples, I'll show you. But in this example, it's very obvious that shape is not a point, so it doesn't make sense to do this semantically. Whereas in here, it is obviously true that a square is a rectangle. Everything that you can do with a square, you can do with a rectangle. So if you substitute square with rectangle, can a flag be square or rectangle? I have